Welcome to our foundation channel. From class 6th mathematics, the chapter number 10 is sets. So let us discuss these are the topics in this. First, let me explain what is set, complete information about that, the definition and all. And next we'll see the properties of sets. So what are the properties we can apply, how to representation of the set, and what are the types of sets. And finally, we'll see the cardinality of the set. So including examples, the definitions, I'll show one by one. First, let us see this word sets. Actually, in our day-to-day life, we'll use the sentence, right? Like a collection of toys, or in a class, if there is 30 strength. So we can say the class strength, total strength of the class with boys, or class of the strength with girls. So just we'll say some sentence like collection of the books, or collect the Telugu books or language books, or all the books you collected with the first language. So and so sentence we can use. A group of boys playing hockey, or else a group of girls playing badminton. So group of students going for picnic. These are all the sentence we'll use. So that means each and every sentence is well defined. So particular meaning we are giving in that. For example, if you say one sentence, collection of stamps. Collection of stamps. So what we are collecting? Stamps only. So is it defined? Well defined it is. That's why set we can use a statement definition like this. A set is a collection of well-defined objects. Objects it is. In the previous statement, the stamp is the object and it is well-defined. So is exactly stamp or not. So collection of well-defined objects is a set. For example, if you take the good books in a library, so we can't say which book is good and which is bad. So that is objects are books, but it's not well-defined, right? Only the collection or else then all the books with English language. So we can say that the book is in English or not, right? That is a well defined. And group of young players. Only if they say the word group of young players. So young players means till what age the young is not mentioned. So it's not a well defined. So we can see only the well defined is we should give particular meaning in that. So we should suppose to say a well defined means it must absolutely clear which object is belongs to the set or which does not. So two options. It may be belongs to a particular set or not. Okay. Let us see the example here. Before starting, let us take this is the set A. We'll use this brace letters. In this example, pair of curly braces will denote the set. Within the curly braces, you can write. This is and the Greek letter epsilon. We can use this for belongs to. The symbol is epsilon. We'll use to word belongs to. See the terminology. Now set A. A is having one set having the elements 3, 6, 9, 12, 15, 18. So these are all members or elements you can say. So now the group of all the numbers or even numbers, odd numbers, some set, some particular meaning is this. Within the braces, we use this 1, 2, 3, 4, 5, 6 numbers. Now this is set A. First question we have to say true or false. 8 belongs to A. Yes. Is there 8? Yes or no we can say it. So 8 belongs to A they mentioned, but 8 is not there in the set. So it's a false. Right. And 12 is not belongs to A. This is the belongs symbol. Same if we keep the cross. This is not belongs to. Okay, you can use the sentence. 12 is not belongs to set A. So 12 is there already in the set A, but this is not belongs to. So it's a false. Next 15 is belongs to A. 15 is in set A. True. Right. 9 comma 12. So this is 9 and 12 belongs to set A. It is true. 12, 14, 15. 12 is there, 15 is there, but 14 is not there. So even though it's false, because they mentioned even 12, 14, 15, all three are belongs to A. The statement is false in this, right? So these are the main we'll use. Just to denote the set, we'll use the capital letters. Like B is the set having elements A, E, I, O, U. So it is well defined. It's only the vowels in English alphabet is we can take it as the set B. Right? Even sets we can denote with capital letters. The members or elements will use the small elements like A, B, C, D. Only A, B, C, D is in set C. So we can say this small e is not belongs to set C. Here is M is does not belongs to set B, or A is belongs to B. Sets we can use capital letters, elements we can use the small letters in case you use English, and members or elements we can use the numbers variables for the set. So the main thing, let us see exactly what is the properties, what the types of sets, how to define various problems we'll see now. Properties of a set. So to do the sets problem, we need to know the properties first. Then we'll see the type of sets and other problems. In this, we have the two important properties. First one, a change in order of writing elements does not make any change in the set. See example. So change in order. For example, set A. Let us take elements 1, 2, 3, 4. So 1, 2, 3, 4 are the elements or members in set A. So change in order. Same way A set I can write even 2, 1, 3, 4. So both are same. Even set A I can write 3, 4, 1, 2. So any order, change in order of writing elements does not make any change in the set. So order change. So change in order does not make any change in the change in the set. So set will be same. So for example, A is this. No, let us take B is one more set. That is 4, 3, 2, 1. That means exactly A and B are same sets. So there is no any change, right? And one more. If one or many elements of a set are repeated, the set remains the same. Even elements are repeated. Let us take one set. Is having A, B, D and A, C, D. So is exactly same as, now this you can write A, B, C, D. So in this A is repeated two times, D is repeated two times, right? So that means A, B, D, A, D also same as is A, B, C, D. If one or many elements are set are repeated, the set remains the same. So there is no change. That means these two are same. So if Q is the set of the word book, so word of book. So book word, if you take Q is the set, this you can write B O K. So should not write B double O and K. O is only letter, should be only one time. That means based on these two, one thing you can notice, elements of the set written inside the pair of curly braces, right? That is already we discussed. Again should be capital letters with set and small letters will use for the set inside. Next, if the elements of the set are alphabet, these elements written in the small letters. Next, the elements of the set may be written in any order, already discussed. And no element of the set must be repeated. So should not repeat any element inside. So if any order you can write does not change and set is repeated also, set remains same. So without repeating you can write. Now let us see these two examples how to solve. First one, write the set of letters used in the word meerut. So therefore this required set is within the curly braces. So you suppose that small letters. So M, E, R, U, T. Now E is two times. So but you write only one time. Next R, U and T. That's all. Next, the write the set of vowels used in the word. Set of vowels they asked. So M, U, S, S, O, O, R, I, E. From this word only write the vowels. So U is there starting. Next O is two times, but write only one time. Next I and E. So A, E, I, O, in that U, O, I, E only are there. Write the set of consonants used in the word. Only consonants. So other than vowels, consonants. That is M, R, T, S. Only one time you should write. A is the vowel, should not write. Again I, those should not write. So M, R, T, S. Next one, they are asking the true or false here. For each statement given below, state whether it is true or false. It's based on the second property. So this first one is true. So reason, as repeated of element does not change the set. Even elements are repeated, set does not change. This is true it is. 347 437. This is also true. So first property, right? As the change in order of writing the elements does not change the set. Next, 6 minus 2, 5 minus 2, 4 minus 2, 3 minus 2. Value. 6 minus 2 exactly equals to 4. And 5 minus 2 is 3. 4 minus 2 is 2. And 3 minus 2 is exactly equal to 1. So it's a true. Even calculations are given instead, but after simplifying get the same, right? So it's a true it is. Okay, these are the basic properties of set, main two important properties. Now let us see the types of the sets. Representation of set. So before seeing the types of sets, let us see exactly how to represent the set. Right, we have the three methods. One is the description method, roster or tabular method, and one more is set builder form or set builder method, rule or set builder method. Let me take one example and I'll show this three type of methods. First we'll see the description method. Right, in this word itself, the meaning we have description, that is a sentence format. So in this method, a well-defined description of the elements of the set is made. So sometimes the description of the elements is enclosed within the curly brackets. Right? Let me take the natural numbers. You know natural numbers, right? Natural numbers starts with 1. If you take this example, set of all counting numbers starting from 1. There's a statement about the natural numbers. So in descriptive method, so natural numbers, I took this example. So first, second, third. So first one is, we can write in the form of description. So set of all counting numbers starting from 1. There's a definition of the natural number. There's only description for the natural number. There's a description method. So first one, set of all counting numbers. Set of all counting numbers. Counting numbers starting from 1. Starting from 1. This is the description method. Now same way for second one, roster or tabular method. So we should write within the curly braces the elements. So this is roster or tabular method. So tabular method means set of the numbers 1, 2, 3, 4. No? So starting with 1, 2, 3, 4 and so on. Within the curly braces, if we write all the elements with commas, there's a roster or tabular method. Next, third one, rule or set builder method. So we can make the rule for this. So rule is simple, within the braces, first x. I'm treating these all the elements within the x, such that x is a counting number starting from 1. So what is the meaning of this x here? X is a counting number. So counting number from 1 it is. Starting from 1. Right? Take one more example. Actually, description method is only writing the statement wise, and roster or tabular method, no. So under the consideration of or written inside the pair of curly braces separated by commas, we'll do it. And ruler or set builder form will make one rule for this, or statement or some formula is made. Okay. If we take some different examples, you'll get more idea, clear idea. First, for example, okay, description method, roster form, and set builder method. 3-1. If A is the set of odd natural numbers less than 15. There's a statement, description. A is equals to set of odd natural numbers. Odd natural numbers less than 15. Okay, so this is the description. Next, this one, roster form. A. So set of odd natural numbers less than 15. odd numbers, no, only less than 15, that is natural numbers. So 1, 3, 5, 7, 9, 11 and 13, right? Within the curly braces, if it's separated with commas, this is the roster form. And same, let us take A is equals to, so we can take X such that here is what is X? X is nothing but odd natural number less than 15. X is odd natural number less than 15. This one, right? The statement we can write. Sometimes rule we can use, some are formula, so we can use this. So description method is statement like this, and next one is the roster form. Elements with the comma separate is X such that X is the each and every element what belongs to, that we can make in this. X is the odd natural number, right? These the three ways we can represent this mostly, and using actually the type of sets and how to represent we'll go for briefly now. Types of sets. So let me explain around 7 types in this. One by one we'll see with example. First one, finite set. Finite set. So you can see the meaning from this word finite. We have infinite, finite, no? So finite is a set is said to be finite if it has limited elements, only the limited number of elements. So any set which is having a limited number of elements. So for example, let us P is the set having elements 1, 2, 3, 4 and close this. So only the limited number of elements. Like Q is the set. Natural numbers less than natural numbers. So description way I'm writing natural numbers less than 5000. Even so 1, 2, 3 up to 5000. So but it is limited. So till 5000 we can say which is the last number or which is the first number. There is a finite set. Right? Whole numbers between 5 to 5 lakhs. So any statement which we can say some the last number we are able to say starting, and all the numbers which are able to say, they are the finite set. So a set is said to be finite set if it has a limited number of elements. Right? There is a finite set. Next one, infinite. Infinite set. Okay, see the meaning in this. A set is said to be infinite set if it has unlimited number of elements. First one is limited, no? So this is unlimited. So n is the natural numbers. Like n is a set having elements 1, 2, 3, 4, so on. You can't say the last number. If the last number is 1 crore, the next followed by 1 crore 1. If it is 100 crores, 100 crores 1. So it's an infinite, unlimited number of elements. So it is having an unlimited number of elements. Even if you write in description method, stars in the sky. This is also one example. So this is unlimited. It's uncountable. We can't say exactly that number. So same way, natural numbers greater than 30. So 31, 32, 33, so on. So this type. So we can, these sets are expressed in roster form by writing only few elements and then putting some dots or some lines to say continuously till infinity. Okay, those we can write. Like W is the set, is having elements whole numbers greater than 30. So 31, 32, 33, few elements you write, keep the dots and close this curly braces. Right? This is the infinite set. Unlimited. Finite is limited. And next two types. Third one, empty set or null set. The empty set or null set. You can say some void also. Null set. It is a set that has no element. So the meaning of empty is nothing, right? So there is no any element. It only there is a empty set. Now set A is having only curly braces, don't write anything in this. So this we can represent to denote as empty set, or the symbol we can use this symbol, null set symbol, circle and just cross the line this. So null set. See some examples also. Let A is equals to triangles with four sides. I took an example, description method, triangles with four sides. Is it possible? Triangle is having only three sides, right? So it's a four sides. So it is a empty set. Set B, natural numbers less than 1. Question is natural numbers less than 1. Natural number starts with 1, but less than 1 is there is no any natural number less than 1. It is empty. So that means B is equals to null. That is B is equals to void or null set or empty set, right? So there is no any element. There is no elements. The set is null set or empty set. Next one, equal sets. Equal set. Next one is equivalent. First, equal set. Two sets are said to be equal if the elements of the two sets are the same. Then we can say those two sets are equal sets. Like let A. A is having elements 1, 2, 3, 4. Right. Again B. B is the natural number less than 5. This is B is the set natural number less than 5. Natural number less than 5 is only 1, 2, 3, 4. Right? That is exactly equals to same 1, 2, 3, 4. So therefore we can say set A is equals to set B. So we can conclude that two sets are said to be equal if the elements of the two sets are the same. Elements must be same. No extra again. Exactly same elements. If there is a 1, 1 also should be here. 2, 2, 3, 3 and 4. Same elements also. Number of elements and same elements. Right. Next, fifth one. Equivalent. Equivalent set. Difference between equal and equivalent. Equal set is element should be same, and equivalent, the two sets are to be equivalent if the number of elements in the both sets are equal. Only number of elements. Consider set A. A is having elements x, y, z. Let's say B is having elements 1, 2, 3. So number of elements will denote with n of capital A. The meaning is number of elements in set A is 3. Number of elements in set B is equals to 3. Elements are different, but number of elements are same. Here is a 3, here also 3. Therefore, A and B are equivalent. Therefore, set A is equivalent to set B. So that we can say, right? Exactly elements are same, equal sets. Only number of elements are same, equivalent set. That means every equal sets also nothing but equivalent. But every equivalent is need not be equal. Remember this, right? And next two types. I'll say 1, 2, 3, 4, 5. Fifth one, disjoint sets. Disjoint sets. See this meaning. If two given sets have no element in common, they are disjoint. Joint and disjoint, no? You can see the meaning. Disjoint. There is no any common element. Say set A is having elements A, B, C, D. Right? And B is the set 1, 2, 3, 4, 5. So A and B are disjoint sets. Set A and B are disjoint sets. Let us take Example, A is set of the students in class 10th, B is set of the students in class 12th. So A and B are disjoint. That means if the two given sets have no common element, no element should be common, no element is common, then they are the disjoint sets. If any one element is common also, it's not disjoint, they're joint. Disjoint, there is no any common element. Okay, remember. Next one, overlapping. Overlapping sets. If you see the elements here, if two given sets have at least one element in common, they are said to be overlapping. If there is no element is common, disjoint, at least one element is common, they are overlapping. So set A having 5, 6, 7, 8, 9, 10, right? And say set B 4, 6, 8, 10, 12. Set A and set B are overlapping because they have some common elements. 6 is here and here, 8 is here, and 10 both. So set of students in class 10th, set of students in class 10th, girls, and for example set A is having class 10th girls, set B is only class 10th students. So there is some girls are common both the sets, right? Here the meaning is if two given sets have at least one element is common also, they are said to be overlapping sets. At least one element. There is no any element is common, disjoint. See the difference. At least one element is common, then overlapping sets. These are the types of sets. You can get the questions like true or false and verify that are equal or equivalent or find empty or not. So those type of questions you'll expect from this type topic. Let us see the cardinality of the set now. Cardinality of a set. So in this, the number of elements in a set is called a cardinal of a number. This is a cardinal number. That is number of elements. Number of elements in a set. So is called cardinal number. Okay, so see already we discussed this number of elements in this equal sets already. See example, set P 2, 9, 11, 14 has 4 elements. So cardinal number of set P is 4. Right? And set M XYZ has only 3 elements. So 1, 2, 3. So cardinal number of set M is 3. Set E has no elements, is empty set. So cardinal number of set E is 0 and so on. So we can denote with small n, that is in first example n of P, that means number of elements in set P is 4, and for second one n of M, number of elements in set M is 3. Next number of elements in set E, third one, there is a 0. So number of elements is 0, nothing, there is no elements. Number of elements in set is called cardinal number, that we can represent as this. Three important things to remember in this. Elements in the set must not be repeated. So it should not be one more 9 or one more 11, another 2. So elements in the set must not be repeated first. Then cardinal number of empty set is 0 and cardinal number of infinite set is undefined. Because infinite. Because discussed no previous empty set and finite and infinite. Infinite set cardinal number is undefined. Right. Let us see the examples. Is a question, write the cardinal number of each of the following sets. So in this, since A is having 2, 3, 5, 5, 3, 3. That means set A we can rewrite 2, 3, 5. 2, 3, 5, 5, 3, 3 exactly equals to 2, 3, 5. Should not be repeated. Therefore, n of A is equals to 3. Right? First one. Should not repeat as per the rule. And set B, letters in the word Nujahan. Letters. So set B we can write in roster form N O. two times is verb, but you should write only one time, should not repeat. Then R, right? Take this letters. And J, A. H is there more. And next A is repeated, N is repeated. So finally we have only 1, 2, 3, 4, 5, 6. So N of B is equal to 6. Next, the third one. P is the set counting numbers between 10 and 30 that are divisible by 5. Between 10 and 30, exactly divisible by 5. So 10 is not there after 10. In 5 table, we have the 15. Next to 20, 25, then 30. But in between 10 and 30, no? So 10 and 30 should not take. Only 15, 20, 25. So number of elements in set P is 3. Therefore, n of P is equal to 3. Or cardinal number of set P is the 3. Okay, this is the finding in the cardinal number. The rule is element should not be repeated. Elements in the set must not be repeated. And the empty set is cardinal number is 0, and same way infinite set cardinal number is undefined, that you can remember. So those are watching the first time channel, you can subscribe to it because you can see the links in order. You can follow the links they're providing in description also about the material and so on. You can see the links in description below. Right, you can follow the series in order to learn perfectly in this topic.